In interviews, sliding window is not about memorizing patterns. It's about knowing when the window should expand and when it must shrink. Today we'll understand the variable size sliding window. This pattern shows up repeatedly in array and string problems. So understanding this properly saves a lot of time. Let's begin.
The problem is we are given an array of integers and an integer k, and we need to find the maximum length of the subarray whose sum is less than or equals to k. Here we are not given a fixed window size. We are only given a condition on the sum. That means the window size can change. We expand the window while the condition is satisfied and shrink the window when the condition breaks. Whenever a problem gives a condition instead of a fixed size, it is a strong hint towards a variable size sliding window. The window is simply the elements between the left and right pointers. As right moves forward, the window expands. The right pointer is used to expand the window. Each time it moves, a new element is added to the current sum. If the sum exceeds the allowed limit, that is k, we shrink the window by moving the left pointer until the condition becomes valid again. In interviews, the most important decision is knowing exactly when the window should shrink. Both pointers only move forward. The right pointer always expands the window and the left pointer only moves when the condition breaks. We start with both pointers at the beginning. As we move the right pointer, we add elements to the current sum. If the sum becomes greater than k, we move the left pointer forward and remove elements from the sum. Whenever the window is valid, we update the maximum length. Now let's understand this using an example. Initially, both left and right pointers are at index 0. We have a current sum variable that stores the current sum of the valid window. Max length variable that stores the maximum length of the valid window. As right pointer is at 0 index and the current sum is 0 currently, so we will add current sum with the value of right pointer. So the current sum will become 2. As 2 is less than k, whose given value is 7. So max length will be maximum of the current max length, that is 0, and right minus L plus 1. So in this case 1. So the max length will be 1. That max length is equals to right minus L plus 1. The right pointer then moves forward to 1 and the current sum will be current sum plus the value at right pointer 3, which is again less than k. So the maximum length will be 1 minus 0 plus 1, 2. The right pointer again moves forward to 5 and the current sum will become 8, which is greater than k. Now when the current sum becomes greater than the value of k, we remove the left element from the current sum. So this will be minus 2. The current sum will then become 6. So we have removed this and the current sum is now 6. After removing the value of left pointer, the left pointer moves forward and the current window is from 1 to 5. Now the right pointer moves forward and the current window increases. The current sum becomes 7, which is equals to 7. As this is valid, the maximum length will be the maximum of current maximum length and r minus L plus 1, 3. Now the right pointer moves forward again and the current sum becomes 10, which is greater than k. So we reduce the value of L, so the value becomes 9. We then move the left pointer forward. This is again greater than k, so we remove the current left pointer from the current sum. The value becomes 4 and move the left pointer forward. The current sum is now less than k again, so we will calculate the maximum length, which is right minus left plus 1. So 4 minus 3 plus 1, 2, which is less than the previous maximum length. So it will not be updated. Finally, right moves to the final element. The current sum becomes 6, which is less than k. So we calculate the maximum length, which is the maximum of previous maximum length, and r minus l plus 1. So the maximum remains 3. So this will be returned as an answer. Hope this is clear. So this is pretty straightforward. When the sum exceeds k, we don't move right further. We shrink from the left until the sum becomes valid again. Each element is added to the window once and removed from the window once, which is why this approach is efficient. Now that the logic is clear, let's walk through the implementation. I maintain a sliding window using 2 pointers, left and right. The right pointer expands the window and adds elements to the sum. I initialized 2 variables, current sum and maximum length to 0. The right pointer expands the window and adds elements to the current sum. If the sum exceeds the given value of k, I shrink the window from left until the condition becomes valid again and increment the left pointer. After that, I update the maximum window length. I intentionally avoid extra data structures here because the pointer movements is sufficient. Let's run the code. So this is the expected output. Uh, Even though there is a loop inside another loop, each pointer only moves forward. Right pointer moves n time and left pointer moves n times. No element is processed more than twice. So the total complexity is O of n since both pointers move forward at most n times and no element is reprocessed. This is a common interview confusion, so always explain pointer movement instead of counting loops. The space complexity is O of 1 because no additional data structure is used. Interviewers are not testing whether you know sliding window as a pattern. They are testing whether you understand the condition that controls when the window should shrink. If you can clearly explain that condition, the rest of the solution usually follows naturally. In most interviews, once you explain the condition confidently, the interviewer is already convinced you are on the right track, even before you finish coding.
Sliding window becomes simple when you stop memorizing patterns and start thinking in terms of conditions. Focus on the condition, the window will take care of itself. Follow the series to build strong interview intuition. That's it for today. See you in the next one.